All right, so looking at our math workshop today, looking at our math workshop today, number one, I've had a lot of people, can I borrow this, Chris? I'll put it back at the end of class. All right, looking at number one, I've had a lot of people that have kind of stared at it and been like, I don't know how to do this. I have a point A and a point B. So do y'all have any thoughts on, like, if I'm looking at this and I don't know what to do, any thoughts on what I could do? If I have point A and point B? Draw the coordinate plane. Let's graph them. If we don't know what to do, it says, which expression represents the distance? So, well, those don't really look like the distance we've done. So let's draw it out and see what it looks like. So I'm going to draw out my coordinate plane. All right, it says A is at negative 6, 4. So I'm going to go backwards. 1, 2, 3, 4, 5, 6. And then up. 1, 2, 3, 4. All right, it's not perfect. It doesn't have to be. So there's A. And then B, it says, is at 3, 4. So I'm going to go forwards. 1, 2, 3, and up. 4. Okay, y'all okay with that so far? All right, it says, what is the distance between A and B? All right, so first of all, guys, how far is A from that line? How far is A from that line? 6, okay. How far is B from that line? 3. So I have 6 and 3, right? All right, so am I talking about 6 and 4? No. Am I talking about 6 and 4? No. All right, these are both 6 and 3. What would I be doing with 6 and 3 to figure out how far apart they are? I would be adding them. Isn't that what that says? So what do you think my answer choice is? No. Hey. Okay. Just because you don't understand a problem, if you're able to draw a picture, if you're able to visualize it, it might help your answer choices make a little bit more sense. Okay. So these absolute value bars, what's the absolute value of negative 6? 6. What's the absolute value of 3? 3. Do y'all see how it's really just saying 6 plus 3? Which is what Chris said, because he said, hey, it's going to be 9. Okay. All right. Are there any questions on number 1? Make sure you bubble that in. Make sure you bubble that in or circle it. All right. Let's look at number 2. Again, we're not using calculators. For number 2, it says multiply the decimals together and input the product, which just means write your answer in the box, all right? So when I'm multiplying decimals, what was one of the tips that I told y'all? When you multiply decimals, what did I tell you as like a little tip? Danny?
Put the decimal in.
We're not even going to write the decimal in there. So we're going to do 23 times 28. Y'all okay with that? 23 times 28. So 8 times 3 is? 24. Carry my 2. 8 times 2 is 16. Plus 2, 17, 18. 0 is a placeholder. Mark that out. 2 times 3 is 6. And 2 times 2 is 4. When I add that up, I get 4. 8 plus 6 is 14. 1, 1, and 4 is 6. So is my answer 644? No, what do I still need to do, Emma? 2 decimal. There's 2 decimals here. So I'm going to move over. 1, 2. So I get 6.44. So guys, yeah, so we definitely want to show our work. So my next one I could do right here, 41 times 11. All right. I might do the next one over here. So 26 or 66 times 26. How far over am I going to have to move when I do 66 times 26? How many spaces? 1, 2, 3. Make sure we move over 3 spaces. All right. And then we're also going to need to do 398 times 54. All right. So do y'all see how I made room to work out all of those? Right. Are there any questions about any more of these? Remember, this one's moving over 1, 2, 3 at the end for your answer. Okay. What about the last one? How many places does it have to move over? 1, 2, 3, 4. we have any questions about these? So you're working them out. I'm going to give you a few minutes to keep working those. All right, Tucker, make sure you're working these for me, okay? So you'll have them. Remember, this is a test grade. That'll take a... All right, so while you're finishing those up, I'm going to start our video for today that goes over kind of what we're going to discuss.
If you know the ratio of students to teachers is 5:1, and you know there are 15 teachers, is there a way to figure out the number of students? In this lesson, you will learn to solve for missing values in a ratio problem by setting up a table. To begin, let's review what's going to be a foundation idea for all sorts of ratio problems. It's the key idea that a ratio can have equivalent ratios, just like a fraction can have equivalent fractions. So you may start with a ratio such as 2:1, and the idea is that you can have as many groups that have this ratio as you want. So for instance, you could have 3 groups of each. And then altogether, you might say that the ratio, because 2 times 3 is 6, and 1 times 3 is 3, is 6:3. The idea is that 2:1 and 6:3 express the same relationship, and therefore they are considered equivalent or equal ratios. So let's look at a scenario to really examine how to use a table when we're solving. Andy has a ratio of books to DVDs of 3:2 in his room. If he has 15 books, how many DVDs does he have? The first step that we're always going to want to do is go through and annotate. I see that my ratio is books to DVDs. It's 3:2, and currently he has 15 books, and what I want to know is how many DVDs does he have? So now that I've gone through and picked out the important information, I want to know, how is that ratio going to help me solve and set up this problem? Whenever I'm working with problems like this, I like to keep a post-it note or just a pencil scratch of the information I know. So we know the ratio is books to DVDs, it's 3:2, we have 15 books, and we're looking for the number of DVDs. Now, I particularly love using tables to solve ratio problems because you've seen tables before. You might have called them input-output tables or function tables, but they all focus on the same idea. We're going to label each column based on the parts of the ratio, in this case, books to DVDs. And we're going to fill in the ratio that's given to us. For every 3 books, Andy has 2 DVDs. Now the idea is that we're going to use equivalent ratios to figure out when Andy has 15 books, how many DVDs does he have? So to start this process, let's think about, well, currently if he had just one set of this ratio, he would have 3 books and 2 DVDs. But what if he had 2 groups? Then he would have 6 books and 4 DVDs. What if he had 3 groups? What if he had 4 groups? And so on and so forth, until you figure out that it takes 5 groups to see that Andy has 15 books and 10 DVDs. Ratios always work in this grouping fashion. That's why tables are especially useful in figuring out missing information. Let's look at that table that we filled out and examine it a little bit more closely. There are 2 key ideas that you might hear when working with ratios. And the first one is the one we kind of already saw, which is that when we're looking at the column of books, each level is increasing by 3, because in every group that Andy adds, he's only adding 3 books. And each group of DVDs is increasing by 2. This idea of ratios is called additive reasoning, because as you move down the grouping, you're going to add each time to find the next number. Now, when we started learning about operations, you first learned about addition, but then you learned about an operation that's based on addition. It's just faster. Can you think of a way to get from 3 to 15 faster than adding 3 plus 3 plus 3 plus 3 plus 3? Hopefully you've remembered that instead of adding 5 times, you could simply multiply by 5. 3 times 5 is 15. We can do the same on the other side. 2 times 5 is 10. This idea is called multiplicative reasoning, and it's based on the same concepts as additive. Just like multiplication is faster than addition, multiplicative reasoning is faster than additive reasoning. In this lesson, you have learned to solve for missing values in a ratio problem by setting up a table.
All right, so that's exactly what we're going to do today. We are going to set up a bunch of tables. So last period I had like big plans, had these beautiful notes.
Good job.
Did not really go the way I had planned. So, what we're going to do, guys, I'm going to pass out our homework. All right? We're going to do 3 of these problems together. There are 10 problems. I know it's front and back. It looks like a lot. But it's because there are tables already drawn out for you. All right? We're going to do 3 of these problems together, see if there are any questions. I feel fairly confident that these 3 problems that we do together will help us. Plus, we have that video. All right, so take one, pass it back. All right, let's look at our notes for today.
If you know,
So let's make that go away and pull back up our notes. Here we go. All right. So everyone should have a paper. Raise your hand if you did not get a paper. All right, everyone's good? All right. Let's look at this first one, and it looks like I might have punched through some of it, so we're going to read it the best we can. It says, to make 5 apple pies, you need about 2 pounds of apples. How many pounds of apples do you need to make 20 apple pies? What 2 things would I be talking about to put in this chart? Josh.
The 5 apple pies and the 2 pounds of apples.
So we're talking about apple pies and we're talking about pounds of apples. Do y'all see where we're getting that from? So that's what I'm going to label in my chart. So I'm going to put apple pies. And then we're going to put pounds, and I'm going to use LB, pounds of apples. Okay. All right, what 2 numbers do I need to put together? What 2 numbers form my first ratio that's given to me? What 2 numbers form a ratio that's given to me? Price? 5 and 2. So we want to make sure 5 goes next to apple pies and 2 goes next to pounds of apples. Okay? All right, what number does it give me? What number am I trying to find out? What number goes with my answer? What number is going to go with my answer? Morgan? What was it?
20.
Yeah, 20, sorry. 20 apple pies. So 20, can I put 20 by pounds of apples? No, it says 20 apple, and that cuts through pies. So we want to make sure 20 goes up on the top with pies. Okay? All right, guys, is it pretty easy to go from 5 to 20? Yeah. What can I do to 5? So in the video, what operation do I have to use to change numbers? Does anyone remember what operation would I be using to change my ratio? You have 2 choices. We can use multiplication or we can use, guys, think about it, multiplication. What goes with multiplication? Division. So we can multiply if it's getting bigger. When would I use division? When it's getting smaller. That logically makes sense, right? Okay. So what would I be multiplying 5 by to get 20? Aubrey? 4. So do y'all agree I can do times 4? Okay, if I do it on the top?
You're going to do it on the
We're
bottom.
going to do it on the bottom. So I'm going to put times 4 here, and 2 times 4 gives me 8. So that first chart was pretty easy. All right, so what would a good answer for this problem be? All right, we can't just leave it in the chart. What would a good answer be to this problem? Kayla? You need 8 pounds of apples. So let's see, you need 8 pounds of apples to make 20 pies. Okay, so obviously the 8 pounds of apples was our answer, and writing it in a complete sentence since it's a word problem. All right, number 2. 4 balls of wool will make 8 knitted caps. How many balls of wool will Malcolm need if he wants to make 6 knitted caps? What 2 things am I talking about for my chart? What 2 things are we talking about in our chart? Chris?
Balls of wool.
Balls of wool and knitted caps. What numbers, Danny, are my first ratio? What numbers make my first ratio? So I have 4 and 8. So 4 is talking about the balls of wool, so that's going on top, and 8 is talking about my knitted caps, okay? What number goes with my answer? What number is going to go with my answer? Kayla? 6. And is 6 going on the top? No, 6 is talking about the caps, so make sure it's really important we've labeled this correctly. So now I can put 6 with my knitted cap, so that's going to go on the bottom. All right, so I'm trying to change 8 to 6. Now it's getting smaller, do y'all agree? So if it's getting smaller, I should be using division. All right. You have to use multiplication or division. You have to use multiplying or dividing. Those are the only options. All right, and we might want to write that on here. Division or multiplication are the only operations you can use. Okay. If it's getting smaller, what would make sense to use here? Division. Do y'all agree? But here's the problem, guys. 8. What's 8 divided by 2? 4. 8 divided by 4? 2. Is there anything else that'll go into 8 easily? Can I divide 8 easily and make it a 6? So this is where it becomes a little challenging, all right? In fact, it looks like it would be hard, but it's not going to be difficult because we talked about something last week called the unit rate. And what does the unit rate do? It makes it a? What number does it make? What's important when I do unit rate? What number is it important that I make? Christy? A whole. I need to make a 1. So guys, I know I can't change 8 to 6 easily, but can I change 8 to a 1 easily? How would I make 8 a 1? What would I divide by? Divide by 8. So I'm going to divide by, if I do it to the bottom, I have to do it to the top. So I'm dividing by 8 here. 8 divided by 8 is obviously 1. That was pretty easy. Y'all agree? Okay. All right, and 4 divided by 8 is 0.5. Okay. Now, guys, can I make a 1 a 6 easily? Yeah. So, guys, if you're stuck and you're like, I don't know how to make it that number. Okay, make it a 1, because now to make 1 a 6, what am I going to do? Times 6. So, guys, you can always make something a 1. You can always make something a 1 and just make it a 2-step problem instead of just a 1-step. Okay? So 1 times 6 is 6. What's 0.5 times 6? 3. So for my answer here, I would say you need 3 balls of wool, for 6 knitted caps. Okay. Questions about number 2? All right. Now, number 3 is a little bit longer. It's a much bigger chart, but it's going to be the same concept. All right, and this one's already labeled for us, so that's nice. It's already got its labels. A punch recipe that serves 24 people, and I can see here's my 24 because that's talking about how many people are served, calls for 4 liters of lemon lime soda, 2 pints of sherbet, and 6 cups of ice. How much of each ingredient would you need to make an identical recipe that serves 12 people? So let's first just start with that first sentence and fill in what we know. It says 24 people, 24 is already there, 4 liters of lemon lime soda. So next to soda, I'm going to put 4. 2 pints of sherbet. So next to sherbet pints, I'm going to put 2. And then 6 cups of ice. So next to cups of ice, I'm going to put 6. Are we okay with that? All right, and what's it asking us to change it to? 12. And I didn't specify this earlier, but you notice every time up here that I was going with my answer, I went all the way to the end. And I went all the way to the end here. Okay. So here we're trying to make it 12. Do y'all agree? So 12. All right, what am I going to do to 24 to make it a 12? Divide by 2. And if I do it there, I have to do it all the way down. So 4 divided by 2 is?
8.
Divided by 2. 2. 2 divided by 2?
1.
And 6 divided by 2? 3. Okay. I'm going to need a little bit more space here to work because it also has a part B. So I'm going to kind of write my sentence over here and say you need 2 liters of soda, comma, 1 pint of sherbet, and 3 cups of ice. All right, so part B says, how much of each ingredient would you need to make an identical recipe that serves 18 people? Now, guys, am I going to be able to go directly from 12 to 18? No. So I'm going to add a little bit more onto this chart. Just making my chart a little bit longer. Y'all okay with that? And I'm going to make 2 spots because I can't go from 12 to 18, so I'm giving myself some extra space. We know we're trying to get to 18. Y'all agree? All right. I can't go from 12 to 18, so what number is it going to be the easiest to make 12? We just did this on the last problem. 1. We can just divide this by 12 and make it a 1. Now, I do want to point out, Chris actually said a different number, and it was kind of smart. I didn't think about it. But if I divide 12 by 2, what will that give me? 6, and then I can multiply by 3 to get 18. So I like that. If you're good with patterns and you're good with like your numbers, guys, you can do other techniques. Me, guys, I'm not too good at it sometimes. Like, I'm just like, show me how to get there. That's going to work every time. Every single time, this will work. Get to 1. Okay? Once I get to 1, then what would I do? Times it by 18. Do y'all see what we're doing? So what I'm going to do, guys, instead of filling in the column, I'm going to go all the way across. And I have a good reason for that. So that first one, 12 or 2, we're going to divide it by 12. And guys, using my calculator, all right, and if you need to sign one out, I'll let you do that in a minute when you get started on your own. But using your calculator, what is 12 divided by 2? Sorry, 2 divided by 12 going to give me? I'm sorry, can I see your calculator real quick, Danny? All right, so we get this weird 0.666. Y'all see that? What does this mean to me?
1 with a 1
Yeah, so I get 0.1, and that 6 has a line because that means it's repeating. Now, guys, is there any way to put your line in your calculator?
No.
No. But what's cool is this calculator is going to remember this answer, right? So what would the next step be? What did we write down? After we divide by 2, we're going to do times 18. So instead of clearing that out and having to type all of that in, which we can't even do because it's repeating, I'm just going to hit times 18 and go ahead and get that answer, which we found out is 3. And that's going to give me those nice numbers that I want for my answer. Does that make sense? So when you get something funky like that, that just means, hey, I need to go ahead and go all the way across to my answer. All right? So let's do the next one. We're going to divide it by 12. Okay, I think we're going to get something funky here too. Anyone got that one for me? Price? 0.8 with a 3 repeating. So again, I'm going to go ahead in my calculator and put times 18. And what's that going to give me? Oh, sorry. I left out the 0. So it's 0.083 repeating. Good? Okay. And when I do times 18, what is that going to give me? Remember, we need to type that all in together. Anyone got that answer for me? Y'all are the ones with my fancy calculators. Emma, did you get it? Okay, thank you, Josh, whose name is not Emma. 4.5? No, 1.5? Okay. Okay, so what is this answer? 1.5. Okay. That's why I need for the person that I call on to answer, not random calls out. Okay. All right, so let's do this last one. We're dividing it by 12. 3 divided by 12. This one should give me 0.25 because I know that fraction is 3/12, which is the same as 1/4, which I know the decimal of. Hopefully remember those decimals. And then we're going to do times 18. And what's that going to give me, Kayla? 4.5. So my servings that I need for 18 people are 3. Oh, let's put you need 3 liters of soda, 1.5 pints of sherbet, and then 4.5 cups of ice. Guys, do you have any questions on these so far? So I know that we were just doing 3, but as you can see, number 3 was really long. It was really like 2 or 3 problems in one. Okay. All right, guys, I am going to send a video going over the other questions on this homework. All right, I'll send a video out for that. But I want you trying the rest on your own. So we have 2 left on this side, and then on the back we have the rest of them. So make sure we do the front and the back. Guys, remember, if you look at the next one, so like number 14, it says, if a hummingbird were to get all of its food from a feeder, 16 ounces of nectar would feed 80 hummingbirds. Do you see how if you look next to those first 2 numbers, it's going to give you what to put in your chart? So here I'm going to have ounces of nectar and hummingbirds, number of hummingbirds, okay? All right, I'm going to let you get started on that. If you have questions, please come and ask me.